Hello, and thanks for joining me in this video where I'll do a walkthrough of using OpenLane. Before I begin, I want to provide some background and context. You can find more information in the About section. This started off as a side project, but given the COVID-19 situation, I thought this project could potentially offer something. What it is it allows you to design and test distribution networks really fast. I think this can be useful when we're thinking about distributing medical supplies or any other critical resources. Traditionally, designing distribution networks takes a lot of effort and time, so I thought this tool that I was developing could be used as it cuts down on the effort and time. So let's go ahead and take a look at how you would use it. I would first log in. You can also create a free account and start using this tool. The app is divided into three main components, where you first build your model, then you run the optimization and analyze the results. In part 1, you start with entering the products that will be shipped in this network. So let me add hand sanitizer. Next, I add nodes. So nodes are either suppliers, hubs, or destinations. So why don't I go ahead and add a destination in Chicago? And let me add a supplier in Houston. As you see, we have updated our nodes list. We go back and add product supply. So for the newly added supplier in Houston, let's say it supplies sanitizer. This is an assumption in the model, and you start off with an initial supply value, and then specify if this supply is constant over time, grows linearly, or is exponential. So let's say it grows 10% over time linearly. One thing to note here is that this model can handle the fact that not all suppliers supply every product. As we just saw, Dallas only supplies ventilators and Houston only supplies sanitizers, whereas other cities can supply multiple products, like Des Moines supplies gloves and masks. Then we can go ahead and add demand in a similar fashion. We can specify the demand parameters similar to the supply parameters. Note again here that not all destinations can have a demand for all products. This gives added flexibility. Once we've added the nodes and specified their demand and supply forecasts, we can go ahead and add arcs. This is sort of a suggestion, but you should always start by connecting your suppliers to the closest hubs. The advantage here is so that products that are supplied by one supplier can reach all of the destinations in the network. Otherwise, that product might not make it to its final destination. So for example, if I added a node directly from Houston to New Orleans, instead of adding it to the hub, the hand sanitizer might not make it to Chicago. The cost details are described in the help section below. Next, I will add an arc from St. Louis to Chicago. Note that we have two-way arrows connecting the hubs. This again allows product to flow in both directions. Having hubs is advantageous because you can bundle up your shipments of multiple products and send it out to the destination. And that's more efficient than sometimes having individual trips. Again, whatever makes sense for your network, you have the flexibility of doing that. Once we're done that, we can go ahead and save this model. This will take us to the optimization page. Here we simply select our network, enter the length of the simulation. So I've entered 5 time periods, which can represent days, months, weeks, etc., and hit optimize. Most of the work is done in the back end, and this message will show saying we can go ahead and analyze the results. We select our network, and this will take us to the results dashboard, where it will provide us the network summary, the products in this network, as well as the supply summary for each product. It's also broken down by each supplier, and you can see the total demand in the background. The same thing is true for product demand summary. Each demand is broken down by the locations, and you can see the supply summary in the background. Inventory summary is shown as follows. Similarly, you can see the unmet demand. Finally, you can see the shipment plan to observe how the product will flow from one node to another. In addition to all these visualizations, you can also download the results Excel. This allows for further analysis. For example, if you want to make pivot tables or any additional charts. This has all the raw data as well as the shipping data. The real strength of this tool is to be able to go back and change parameters to see how your network will react. This is a toy example shown with different cities across many states. But this can be modeled within a state or within a city or within a region. So there's definitely a lot of flexibility. So if you think there's any potential in this idea, I would definitely encourage you to share this. I'm hoping it can again serve as a starting point to start modeling a network. This was mostly built from self-taught material, so I know there's a lot of areas of improvement, and I've mainly focused on the core functionalities so that somebody can use it. Nonetheless, I do welcome all of your suggestions, comments, and feedback. Once again, thank you for your time and considering this idea. Have a nice day.